Okay, just one last time. I remember for the last people who connected just now, please note that the webinar is recorded and it will be published on our website. All attendees are muted. In case of any questions, please raise your hand and I will contact you privately. Thank you and enjoy the webinar. And now my colleague Pino will present you the topic of today's webinar. Thank you very much.
Hello, everyone. Can you hear me?
Yes, I can hear you.
Okay. Welcome to this technical webinar focused on how to use our joining systems better, not how to use them, but how to program at the best and to receive the best performance from the use of the spindles and the joining system, together with the mechanics, with the interdrive, and of course the maXYmos NC in all its functions and features. This webinar will be held primarily from my colleague Peter Balzer, which is an application specialist for this kind of for these products, directly from the production center Lorch in Germany, where we produce these devices. So I will end up the presentation to Peter Balzer, which will show you, of course, some slides of presentation and also all the instruction and feature of the maXYmos NC will be shown to you live, because he is connected directly to a maXYmos NC with his laptop. So all the things and all the functions that you will see and parameters that you will see will be live. So is what you as a programmer or user of the joining system will have available on the machine. So I hope you enjoy these webinar sessions, and I hope it's useful also for your next job. Thank you very much for your attention. Peter, are you there?
Yes, I'm here. Welcome, everyone, also from my side. My name is Peter Balzer, I'm application specialist for our joining systems. And I would like to start with a small presentation first. So hopefully it's in the right view, the whole presentation.
Yes.
Yes,
okay,
yes, we can see.
Okay, perfect. So I would like to start with a few slides. So the topics are first I would like to start with a short system overview. I would present components, the different type of our joining modules, a few words about the interdrive, and of course the maXYmos NC. Later on, like my colleague already said, I would directly connect to a maXYmos NC live, and I will guide you through the first, I would say, basic setup. It starts with the global setup, how you can configure your different sensors on the x-axis, on the y-axis. We talk about the cycle control, the field bus settings, NC settings. This was the global settings. And then we go into the measuring program setup. I show you how you can work with the sequence editor, how you can set up an easy evaluation and process view, part ID generation, and so on. So this webinar will contain some basic informations first, and later on the basic commissioning of the maXYmos NC in the first level. And later on with the other sessions of the webinar, we go more and more into the details like sequence editor, like the specific things regarding the evaluation and so on. But we start first with the basic information. Okay. So the first thing I would like to show you is the overview of our complete system. So in this case, we are starting with our, let's say, standard spindle. It's the so-called Ncfh. Here you see a motor of Bosch Rexroth. It already contains an absolute encoder, so this means a displacement sensor, and we have a strain gauge sensor inside of the spindle housing here in this case. Then we have our standard intradrive from Bosch Rexroth. We are working with Bosch Rexroth together since many, many years. We used also in our earlier systems the previous version called EcoDrive. Now we're using the intradrive C and also the intradrive CS, depends on the used type of joining module. For the intradrive C, we are also using the so-called safety zone box. The safety zone box is more or less the connector for all safety guards. If you're using an e-stop, emergency stop, and light curtain, some safety doors or whatever, this is the connection for it. Then we have our MEM, it's called measuring module. Measuring module is the maXYmos NC. It's more or less the same. Maybe you already heard about the maXYmos TL. It's more or less the same hardware with one difference. Here we have a Circus port, and the Circus port is used for the connection to the intradrive. So we are only working with one wire between the maXYmos and the intradrive. It's the Circus free connection. And optional, you can use a DIM, a display module, or what's also possible, this is what I show you later when I'm configuring the device, is the so-called VNC connection, the remote control. Both is possible. The measuring module is directly connected to the force sensor of the spindle, and the absolute encoder, the displacement sensor, is connected to the drive. And displacement informations are transmitted via Circus to the measuring module. And of course, the machine interface PLC is now later on controlling the measuring module, starting the process, choosing the program, and so on via Fieldbus, Profibus, nearly everything is possible. And of course, if you are talking later on in the third part, I guess, about the data export, here you can also connect an PC for some data export, CSV files, XML files, QDAS, and so on. There are a lot of possibilities. Okay, so the first thing I would like to show you is some standard joining process. So we have on this side the maXYmos NC for the parameterization and also, of course, the evaluation. On the right side, we have our joining module, which is later on doing the joining process. We have the motor, spindle housing, and the RAM. Like I already said, inside of the motor, there's always a displacement sensor included, and a force sensor is built inside of the housing. So in this easy process, we just want to push a bearing inside of a bushing. So it starts with the idle stroke. This is the fast movement before we are reaching the part. Then we are switching to the joining stroke with small speed till we have reached a final position or maybe in target force. And then we are going full speed back to the home position. So that's a quite easy process. Our system, or the maXYmos NC in the background, is collecting the displacement sensor information over the drive, Circus free connection, and the force information directly from the force sensor, which is built inside of the spindle housing. So therefore, we can display a force displacement measuring curve, and we can set with the maXYmos NC some evaluation objects. There are many different types. We are talking in the next part in the detail about it, and then you can figure out if the part fulfill all quality requirements or not, if it's a good part or a bad part. So that's the general information about a real basic joining process. Now I would like to continue to show you our different type of joining systems. So you already saw this one. This is the so-called Ncfh, our type 2153A. It covers a really wide measuring range from 5 up to 300 kilonewton. For this case, we are using a strain gauge sensor. Stroke is normally up to 400 millimeter, and we have a practical repeatability of 0.01 millimeter. The maximum speed is always depending on the size of the joining module. Direction of measurement is compression and tension, and we have some features with this one. I already said it. It covers a really extremely wide measuring range, and because of this modular construction kit, we are allowed to make some special solutions. For example, we made some special types up to 600 kilonewton maximum force, strokes up to 1000 millimeter, a 100 degree motor would be possible. So it would be 180 degree angled, and it would have a belt, and of course for safety reasons, we can also optional include a safety brake, for example, for some light curtains or something like this. The next type is the so-called Ncfh. This is our high-end system. It's also covering a big measuring range from 1 up to 60 kilonewton with 2 different sizes. Here we are using a piezo sensor inside. Stroke depends on the size, small one up to 200 millimeters, the big one up to 400 millimeters. Same repeatability, and the movement speed is always 300 millimeters per second. Direction of measurement is also compression and tension. Some features here, we are working with an hollow shaft drive. This means the ball screw is driving through the motor. That offers the customer a really compact design. So here we have 200 millimeter stroke with a really small overall length. It's a direct drive, so we are not working with any gear or a belt in this case. It's extremely dynamic. The integrated piezo sensor offers 2 measuring ranges and an increased overload protection. So in this case, for example, you can configure your spindle up to 50 kilonewton, 15 kilonewton in the big measuring range. And you can choose, for example, 2 kilonewton for your second measuring range. And you can work in both measuring ranges with the same accuracy. So that's a big advantage of our piezo sensors. And reduce spare parts because only 2 sizes covering a broad measuring range from 1 up to 60 kilonewton. The next spindle is a little bit a special one. It's the so-called Ncfh. And this spindle has here some trapezoid design. And this spindle was more or less developed only for one application. It's the cylinder head assembly. We are working with a force range up to 25 kilonewton. Also in piezo sensor, stroke is fixed 350 millimeter. Same repeatability of 0.01 millimeter and 250 millimeter per second maximum movement speed. Compression and tension measurement is possible. You already saw it. It's a slimline trapezoid design, saves space when you are installing it in a very confined area. So this spindle was used for, you can put 2 of them together from the other side, and then you will get a small center distance, only 70 millimeter. If you want, for example, if you're working with cylinder heads and you want to press in 2 valve guides or 2 valve seats at the same time, you need a small distance, a small center distance. That spindle is used for mainly. We increase the guide accuracy with the integrated linear guide, and of course also a piezo sensor is used for 2 different measuring ranges. Normally the seat has a little bit bigger force than the guide, so you can switch the different measuring ranges for the same accuracy. The next one is also a little bit a special one. That's our only rotary axis at the moment. So it's more or less 2 times an Ncfh. We showed you a few slides before. Here we can go up to 50 kilonewton force and up to 50 Newton meter torque. The torque sensor is built in here. It's only an option. You can also only rotate without any torque measurement, but if you want to do a torque measurement, it's also possible with up to 50 Newton meter. We are using a piezo sensor also for the force and a strain gauge sensor with included amplifier for the torque signal. Stroke is from 0 up to 400 millimeter, and we can go up to 80 turns for the rotary movement. Practical repeatability, like always, 0.01 millimeter. Maximum speed is 400 millimeters per second and up to 1000 rounds per minute, the rotary movement. Compression and tension movement is possible, or measuring is possible, and more or less the same features like the Ncfh. We are also working with a hollow shaft drive. We have a compact design, no drive, no gear, no belt, and so on. And this motor here is used for the linear movement, and this motor here is used for the rotary movement. Okay, the next one is our smallest one. This one is I'm also using with the demo unit later on the live setup. So this is our smallest one. It goes up to 50 Newton, up to 1,500 Newton. We are using a piezo force sensor. Stroke is up to 100 millimeter, and we have a really high practical repeatability, lower than 0.002 millimeter in fast movement speed. Compression and tension measurement, like always, also in dive. We are working without a gear, without a belt. It's extremely dynamic, and the really good thing in this spindle is Here we have a transmission via telemetry. This means here in the tool holder, we have put it in our piezo sensor. So this means all the mechanical friction during acceleration, deceleration, and so on, for this type of spindle has no influence on the force measurement because we are directly measuring the ram, so we are quite accurate, and we don't need any cable connections or something because the transmission from the force sensor to the charge amplifier is done via telemetry. And we have an excellent overload protection with low press forces. So for example, if you order this one with 1,500 Newton, you can go up to 1,000 Newton without damaging the force sensor or any mechanical part. That's quite a big overload protection in these low force ranges. Okay, the last spindle is our price optimized spindle. It's the so-called Ncfh. We are covering a measuring range from 10 to 80 kilonewton. We are using a strain gauge sensor. Stroke is from 0 up to 350 millimeter. The repeatability is 0.1 millimeter, and the movement speed depends on the size. With the big one, we have 200 millimeter per second, and with the lower ones, 250 millimeter per second. Only compression measurement in this case is possible, and as I already said, it's a price optimized joining module for some simple joining processes. And the good thing is, with 3 sizes, we are covering also a measuring range from 10 up to 80 kilonewton. Okay, so that was the mechanical part for the joining modules. Now a few slides about the different drives we are using from Bosch Rexroth. So here you see the IntraDrive C. We have the power section, control section, firmware, shield connection, line filter, safety zone module. It's a complete package. This package is in our production pre-configured for each joining module, so the parameters will be overwritten, or it will be parameterized from our production regarding the connected joining module. We have the Circus 3 communication to the maXYmos NC with 250 microseconds, so real time. We have the safe motion on board, SMES. We're talking about safety on the last part in the details. So we can do applications up to performance level E is possible, and parameterization and diagnosis via Ethernet. One port here we are using for the maXYmos NC, and the second one you can connect a laptop or anything else. The second IntraDrive we are using, this is only for the Ncfh at the moment. It's the so-called IntraDrive CS. It's the smaller one. Also, the price is better. So we are working more or less the same functions. We have instead of 250 microseconds for circuits, we have 500. So it's a little bit lower the reaction time, and we are working only with STO, safe torque off. Safe motion in this case is not possible. That's the only difference between those two drives, more or less the safety. And the last slides regarding our maXYmos NC. So it has an integrated sequence control for maximum flexibility. So I can show you this later on when we are talking about the sequence editor, real-time process control with Circus, high performance control and evaluation functions. We are also offering some live evaluation objects to directly interrupt your process if it's needed. We have a uniform operating philosophy also to the maXYmos TL and maXYmos BL. So the handling is more or less the same way. Everything is on board: Profibus, Profinet, EtherCAT, Ethernet IP, and so on. Low spare parts inventory because it's only one type. There are not many mechanical options. It's only one type. And here we have the sensors you can connect in potentiometer, process signal, plus minus 10 volts, incremental, inductive, LVDT, SSI, and so on. For the channel Y, we have a piezo, strain gauge, or a process signal of plus minus 10 volts. Visualization can be done with a display module, or what I'm doing now via VNC. Interface, we have, I already said it, but we also have 2-port Ethernet switch and 3 USB ports for some connection with a pen drive or directly to the PC. Okay, so now I will continue the live session with these demo units. Here maybe you saw one of these already. So these demo units are often used from our site for training. So also if we want to present our products to new customers. So here we have the small NCFT, the spindle I just showed you. Here we have a small rubber to apply some process force. Here in my In my setup, I just implemented a small screw inside of this rubber to implement a real hard mechanical block. So the force will rise at the end of the curve. Here we have the maXYmos NC. We have an Siemens HMI, which is also used for PLC. We have 3 switches to simulate some safety functions. And what you don't see here in this case is the intra drive and the safety zone box, which is also included here. So that's a complete system, a real system with small size. Okay, so that's it with the presentation. Now I would like to continue with the live session via VNC. Okay, so what we have done here now is I just resetted this device to the factory settings. So now all parameters are completely empty. So you can do this one if you go to service, reset, and if you go to the device will be reset to the factory settings. I don't do it now because the device will reboot, and I done this also previously. So this is how you can set your device back to the factory settings. So, okay, before we start with the basic setup, I just want to show you the 3 different areas. So everything with a blue background is the so-called process area. So later on here, we will see the current curve. The next screen is some easy traffic lights. So here you can go get a smiley, good or bad, or thumbs up, thumbs down. So quite easy to see for the operator if it's a good or bad part. Later on, if we added some evaluation objects, here you can see some statistics regarding the evaluation objects. So you can directly see which evaluation objects forces the most NOK parts and stuff like this. The next thing is the so-called process values. Depending on which evaluation object you have chosen, you can set up some evaluation objects here, which you want to show the values of. Then we have a so-called instant view. Instant view, like the name already says, later on when we are driving in process, here you can see the displacement signal increasing, and you can also have a look at the live force. This page is also often used for some calibration, for example. And of course, you can also have a look at the plus peak, minus peak for force, and also for displacement. Also, we have some history curve buffer. You can select 500 curves, but there's also an option available since our latest firmware version where you can store up to 5,000 cycles inside of the device. Then you can select some easy filters, which measuring program you want to choose, result good or bad, and later on you can also select some part ID if the PLC sends some part ID before the pressing is done. And the last page on the process area is the so-called sequence page. This sequence is quite useful if later on, for any reason, some troubleshooting, for example, you have a lot of motions, a real difficult sequence, and the maximum force is exceeded in any motion, then it will directly show you on which motion or what is occurring this error. That's quite useful for some troubleshooting. Okay, the next the next area is the so-called setup area. It's always with this orange background. Here we have our global setup, we have the measuring program setup, and we have the measuring program manager, where you can later on easy copy some programs. You can rename them, put them on the pen drive, and so on. I will show you this later. And the third area is the so-called service area. Here you can have a jogging mode, so you can directly drive the spindle from the mouse NC independent of the PLC. There's a jogging mode available and also an automatic mode. Then you can have some system informations if you want to have a look at the firmware version for the serial number and so on. You can do some digital I/O tests, field bus information, and so on. So these are generally the 3 different areas. So now if we want to set up our maXYmos NC from the beginning, we should start with the global setup. So let's go to setup, global setup. And here, first of all, you can choose your language. So in the meantime, a lot of abilities. So I hope everyone finds his language. We can continue with English. And it's always the same thing with the maXYmos NC. If you want to save the changes, press yes. If you want to exit the menu without any saving changes, press X. So the first thing we need to take care of is the channel X. Channel X, we can have a look at the sensor type, and here's always a short which sensor input is used. For example, if we would have an external sensor, incremental, for example, TTL, you can see directly where the sensor should be connected. So in our case, we are working with servo. Servo means we are using the internal built-in absolute encoder inside of the motor of the joining module. And before I showed you, or I explained to you that the displacement information is directly coming from the drive. So the drive will read out the encoder information from the motor, and the drive will transmit this displacement information via circuits 3 to the maXYmos NC. So that's why the setup is quite easy. So you can choose first of all your decimal places. So it makes sense to work with 2 or 3, depends on you. And the used range for the beginning during the commissioning is always depending on the maximum stroke of the joining module. So here we are working with the small NC with a maximum stroke of 100 millimeter. So this setup is fitting for us at the moment. So here we can skip this one. We can talk about this later in the details. Here you can configure some sensor tests and do some measurement, do some master measurement. If you have questions regarding this, we can do it later, but not in the basic setup first. Okay, so channel X is already done. So this was quite easy. Now we can continue with the channel Y. So channel Y, you can also choose your sensor type, depends on which joining system you have connected, the Ncfh using a plus minus 10 volt signal. The other option would be strain gauge. So normally sensor type piezo is never used within joining system. We have piezo sensors inside of our of our joining modules, but normally or in every time we have already a charge amplifier directly inside of the spindle. So this means the sensor is creating a force out in charge output, but this charge output will directly transformed into a voltage output on the joining module. So the joining module will transfer a voltage signal to the maXYmos NC. So this one is the right configuration if you are using a joining module with an included piezo sensor. The problem is if we would use this piezo cable, well, it's very thin and it's really fast broken. That's why we prefer to apply a charge amplifier direct in the housing of the joining module, so we can use an easier cable with a bigger diameter. Okay, so this one is the real setting for NCFT. So now we continue with the used range. The used range depends on which joining system you are using. So in our case, the NCFT has 2 calibrated measuring ranges. So it goes from 1500 Newton for the measuring range 1, and the second measuring range is 500 Newton. So you can have a look at the calibration certificate from your spindle to see which measuring ranges you have. And of course, the more important thing is what is the sensitivity value. You can also, if you have an Ncfh, for example, you can also freely choose kilonewton instead of Newton. But in our case, Newton makes more sense because otherwise we have 1.5 kilonewton or something. Depends on what you would like to see. So we are working with Newton without any decimal places. Sensitivity value is written on the calibration certificate of each spindle. So normally it should be around 8 volts. So it could be for some spindle 7.5, 7.7, 7.9. This always depends on the configuration of charge amplifier and sensor, but it should be more or less 8 volts, something around that area for both measuring ranges. So the next thing is you can look at the 0 point of your sensor. Here you can use the teach function. So you will see with some piezo spindles it doesn't make sense to use this function, because every time when you're starting the measurement, the force sensor will be automatically resetted. But if you are working with a joining system with a strain gauge sensor, this is not the case. So that's often used. You can use this function often when you, for example, mount a heavy tool on the spindle. Then you will see you have 0.1, 0.2 volts, something like this. And then if you start a measurement, you will get an offset. So you will never start at exactly 0 Newton. You will start with an offset depending on the weight of the tool. But with some piezo spindles, you can do it, but it doesn't make sense, or it makes no influence if you do it not. The next step is you can select your filter function. This is a low-pass filter. You can, for the commissioning, I always like to switch it off so we can use the full 10 kilohertz of the device. The normal setup could be like 500 hertz. This is what our production is still using. Here we have some reset signals for the charge amplifier. Please do not change. Otherwise, you may select the wrong measuring range and you may switch the reset and operate signal from the piezo sensor. And the sensor in this case, we can switch off. So we are only working with this built-in piezo sensor. Okay, so that's the setup for the channel Y. So let's continue with the cycle control. The control, you first of all can select your measuring functions. So there are a few measuring functions available. The normal measuring function is force depending on displacement, force depending on time. You can also measure displacement depending on time, and force depending on time and displacement, and so on. But we are using in the first step only force depending on displacement, and later on sometimes it makes sense to switch it force depending on time when we, for example, working with a force feedback control. Then you can see exactly over the time how the force is held constantly on the part. But for the beginning, we are working, like I already said, with force depending on displacement. So sampling rate is normally automatically done depending on your used range from the channel X setup, but you can have also the possibility to set up a manual sampling rate. So for example, if you set up let's switch it to 0.1 millimeter. So now every 0.1 millimeter here, the device will record an X measuring point and the according Y measuring point to it. So displacement every 0.1 millimeter. But we also implemented in a delta Y sampling. For example, let's switch it to 10 Newton. So if the force is significantly changing between 0.1 millimeter, for example, imagine you would have here a peak something like this, you wouldn't see it with only this delta X sampling. So that's why we also implemented that sampling. So if the force would increase more than 10 Newton in this case, you would have an additional measuring point in between the 0.1 millimeter. So that's the manual sampling. But for the beginning, we can also switch it to automatic. Then we have a measuring range from 0 up to 100 millimeter, and we should have a sampling rate of 0.2 millimeter, something like this. Okay, the next setup is, here you can choose if you want to cut the curve or not. For example, our measuring system is always using is always measuring the forward direction and also the backward direction. maXYmos TL, for example, you can use this function. You can cut the curve at turning point right. Then you may have to make the decision, what is your turning point right? Is it the maximum force? Is it the maximum displacement value? It always depends on the application. So in combination with the distance, we don't need this function, because normally we can stop the measurement before we are going back to home position. And then the measuring will automatically be stopped, and we won't record the backward direction curve. So in this case, we don't need it. Start and stop is use digital input. So this means we have a threshold X, threshold Y, and the same for stop, or you can also use the time. Digital input means these are the symbols from the sequence editor I show you later, or directly the input from the PLC side. This is these abilities, but it doesn't make sense to start the measurement with a threshold with joining systems. Okay, there's some timeout available here, for example, of 60 seconds. So if you have some cycles or some applications where you want to hold the force over a long period of time, you need to increase this. Otherwise, you will recognize that exactly after 1 minute, the measurement will be stopped automatically. But in our case, we only have a few millimeters to drive with short cycle. You can leave it at 60 seconds, but you can also decrease it down to 8 seconds or something. If in the case that something goes wrong, the measurement will be stopped automatically. Okay. So now we have set it up the three most important things: the channel Y settings, channel X, channel Y, cycle control. The next thing is the field bus screen. I don't want to go into the details here. I just want to show you how you can activate the field bus. It's done quite easily. So here you can see, like in the presentation, you can activate Profibus, EtherCAT, Ethernet IP, or in my case, with the Siemens PLC, we are working with Profinet. Data vault interpreter, you can Siemens, so it's if the low byte or high byte is further, so in this case it's Siemens. And we do not work with an IP address at the maXYmos NC, so we are only working with a station name, like it's usual with Profinet. So later on to do the connection, you can set up the station name, for example, maXYmos NC in your PLC hardware configuration, and then you can send the IP address, the given IP address from the PLC to the maXYmos. So that's quite easy. Okay, then that data exports we are talking about later in another part. Also the network settings. It's not hard to see the network settings. So here you can choose address. It's used for both. Connections. Here it's a switch, so we don't have two separate IP addresses in this case. So here you can change the IP if you want to. And then we can continue to the second page. The second page, I would like to show you the NC settings. So here you can set up some global limit values. For example, you can limit your maximum jogging speed. Normally it's 10 millimeters per second, and it's also the maximum because everything lower than 10 millimeters per second is safe speed. So you can go up to 10 millimeters, but you can also reduce it if you want to. You can also limit your jogging area. For example, if it's not allowed for any mechanical reasons that you're going back to 0 millimeter, you can also set up a minimum limit of, let's say, 10 millimeters or something like that. And then no one is able to jog lower than 10 millimeters. So there are just some global limits you can choose here without any influence on the drive. So you don't need to connect to the drive and change some hard limits. It can be everything done here on the maXYmos NC. The same thing. Also, you can limit your jogging, your automatic area here from 0 to 100 millimeter. You can also choose 10 millimeters or something like that. And then you can avoid any crash if it's necessary to do it. Reference speed, you can freely choose. You can also go higher to filter and reference position. So what is reference position? So each measuring program you can configure up to 128 different measuring programs. And for each measuring program, you can have a separate home position. So this means in measuring program number 1, you can, for example, have 50 millimeter as a home position. In the measuring program number 2, you can, for example, have 100 millimeter as a home position. So, but then it's necessary to choose the right program. Otherwise, you will go to the wrong home position. The reference position is for all measuring programs the same. So if you want to have one global reference or home position, you can use this one. It's another PLC input for the PLC programmer. You can go back to home position, and you can also go back to reference position. Both is possible. Okay, here's the switch. You can choose automatic power. So if you have a look at the device from the PLC side, and all safety and the safety area, so there is no problem with some safety. You can power on the motor, and then you can set the input run sequence. If you don't want to how can I say, manually power on the motor every time, you can set this switch, and then the PLC programmer can work with only one sequence. So this is just a little bit easier. If the customer or the PLC programmer want to use it, you can do it. Okay, the next thing is the so-called brake test. So our system offers, in combination with the IntraDrive, an automatically performed brake test. This is only for the holding brake of each spindle. That's important. It's not possible with the safety brake at the moment. So what happens if I activate this one? A timer will be enabled in the inside of the drive, and then the holding brake will be checked automatically. So the holding brake will be closed. Then the drive is calculating his actual current depending on the holding torque of the brake. With this calculated current, the drive is driving against this closed brake, just simply to check if the holding torque is still or if the brake is still able to hold the holding torque or not. This test will be performed every 8 hours automatically. But there's also a possibility, if you disable this one, you can also perform the brake test manually, for example, at the beginning for each shift or something like this. So our system offers a holding brake test frequently, can be performed automatically or manually, doesn't matter. But if you want to make sure that the RAM isn't moving because you are working with a heavy tool and you don't want to get the operator insured, you can use this brake test if you want to. Okay, so that was the real basic setup for the maXYmos NC. We've talked about the channel X, channel Y, cycle control, field bus, network, and the NC settings. So now we continue with the measuring program setup. So measuring program setup. Here you see these 128 possible programs you can choose. We can first of all entering the measuring program manager, because here we are working with only one measuring program. So with this measuring program manager, you can give the program name. For example, let's name this one training. And you can use this button, unselect all, and only activate this one. This function, all other programs are not active anymore, and you don't see them when you're entering the measuring program setup. It's always if you're working with one, or let's say up to 5, 6, or 7 measuring programs, if you deactivate the ones which are not used, just to make it a little bit more comfortable. Now you see only one program is active, and you can only choose this one for the changes. Okay, each measuring program contains the sequence editor, the evaluation. We have some switch signals, output signals, some process view, and the part ID generation. What is also a good thing if you're working, for example, with some external sensors. For example, you have connected an external incremental sensor, or also an external force sensor somewhere in the bottom of your machine. You can do the same setup for channel X, channel Y, and also the cycle control for each measuring program, like we just did it on the global setup. Then you have the possibility to, for example, work in the measuring program number 1 with the internal force sensor, but an external displacement sensor, and in the measuring program number 2 with the internal displacement sensor, but with an external force sensor, and so on. So you can freely choose it from measuring program to measuring program. That's a big advantage. If you don't want to use it separate, you can just make sure that this checkbox is active, use settings from global setup. And if you're working with a spindle with an included piezo sensor, here is the way to change your measuring range. So for example, if you know, okay, I'm working inside of this program only with forces lower than 500 Newton, you can select this measuring range, then your accuracy will increase immediately 3 times. So in this case, we're working with 800 Newton, so let's use the big measuring range. And the same thing for the cycle control. So it gives you the possibility to, for example, do exactly the same cycle in measuring program number with force depending on displacement, and in the measuring program number 2, force depending on time, for example. We will work with that later on when I explain you the force feedback control in another part of this training. Okay. So before we are entering the sequence editor, I would like to show you how you figure out your positions you need to type in inside of the sequence editor. So we have generally, if you remember that slide at the beginning, we need at the beginning 3 different positions. The first one is the home position, can be more or less every time 0 millimeter. Then we need the idle stroke position. Idle stroke position is always before we are reaching the part. And then we have always a joining position to reach, for example, a target position, or if you want to shut up at some specific force, it should be oversized a little bit. So, okay, now you can simply power on this the motor, then also the holding brake will close. And then you can drive here. You see now the spindle here in my office is actually driving, jog plus, jog minus. And this button here is used to go back to reference position. So it will end up at 0 millimeter, or you saw it before in the settings screen. This value can also be changed. So now I'm just driving just close to the rubber in this case. Will reduce my jogging speed and I will reduce my force. I just want to touch the rubber. So let's go quite slowly. Should be something 76 or something. And the force should increase. Nope, now it's slowly increasing. And you see I'm still pushing the button, but the spindle has already stopped. So this is the limit. The spindle won't go higher than 100 Newton in this case. So now we know, okay, we have 100 Newton at 78.8 millimeter. If we go a little bit back, okay, still empty. You should put in a little bit of reserve. So 75 millimeter sounds good for the position of the idle stroke. So this is the position before we are reaching the rubber inside of this demo unit. So now I want to figure out our joining position. So I'm just increasing the maximum force up to 800 Newton. And now we can go up to 800 Newton. Remember, there's the screw inside, so the force will increase. So now, okay, we are on a hard mechanical block. Now we have about 81 millimeter. So now we know 75 millimeter is our idle stroke position, and 81 millimeter is the joining stroke position. So now we can go a little bit faster back. Then we can use these 2 values to set up our first easy sequence. Okay, so now we are leaving the PLC screen, the jogging mode screen, sorry. Let's go to setup, measuring program setup, program number 0. And now we are going into the sequence editor. So here we have the sequence editor. It's more or less like an easy PLC sequence. So first of all, we want to start a measurement. This button is used for, and we also want to stop the measurement at some point. So the next important thing is, so we are talking about the sequence editor in the detail on Thursday. So if you're interested in, I explain everything here in the sequence editor. Now I just want to explain the really, really easy things we need now. Some motions, this button, measurement, stop, and that's all. So first of all, we are starting the measurement, and we are using a motion. So motion can have any description. It's easier for the one who's also working with the machine. For example, you can give that one a name, for example, idle stroke, and then everyone knows, okay, that's the idle stroke and not only motion or something. Reference can be absolute or also relative. So this means 25 millimeter were now reference, what I just measured with in the jogging mode, were reference to the absolute position of the spindle. So now we can use 75 millimeter. If you don't want to reference it or want to have it referenced on the 0 point of the spindle, you can also choose relative. And then the spindle, before he drives or before the spindle drives, is checking the actual position. And then we can drive, for example, only 5 millimeter from the actual position. Or what's also possible, this is always good if you want to release the part, for example, you can also set up a minus value. And then if we are at 0 millimeter, it doesn't work. But later on, to release the part, relative is also good. I will show this one later. So now let's work with the absolute position, 75 millimeter speed. We can go up to 400 millimeter per second, but let's do it a little bit slower with 200 millimeter per second. And the good thing is, now every motion of the spindle can be mirrored with a maximum force. So if something went wrong, for example, someone is inserting part or someone have chosen the wrong measuring program, it always makes sense to reduce this maximum force limit to a lower limit, let's say, for example, 100 Newton, just to make sure that something is happening during home position and is 75 millimeters, that the spindle will stop and an alarm occurs. That is what's going to happen when we exceed the 100 Newton before we have reached the 75 millimeters. Okay, so that was the idle stroke. Now we need another motion for the joining stroke. So we can give this one also a name, for example, joining stroke. Then we just figured out about 81 millimeter or something. It's always necessary, especially if you want to shut off at a force like we do it now, that you give the system a little bit of a reserve. This means if I would type in exactly 81 millimeter, it can happen that we have reached 81 millimeter, but we haven't reached our target force. So it makes more sense to give at least 1 or 2 millimeters reserve at this position, just to make sure that the system has the possibility to shut off on force, because otherwise we will stop too early and you haven't reached the force. You will notice this one with the evaluation objects, but just for information, if we shut up on force or shut off on force, it always makes sense to set this position value a little bit higher than you need it. Okay, so now you saw also in this motion, we have a condition to jump to the next step. So at the beginning, measurement start is clear. When the measurement is started, we are jumping to the next step, and then the spindle will start to drive. In this case, from 0 down to 75 millimeter with 200 millimeter per second. And we have a look if the force is higher than 100 Newton, then the spindle will stop. And the condition to jump to the next step, this means if the 75 millimeters is reached, we are jumping to the next position. But now we want to change the condition position to force. We can go to advanced configuration. And now you see there are different possibilities what you can use. A simple force, a fresh, for example, let's make 800 Newton. You can use a force feedback control, or you can also use an inflection detection. We are talking about the other functions on other parts. Now I just want to show you how it's working when you just want to shut off easy on a force threshold. You can select approach from below, from above, if you're working with an pull application, for example, or the force can also be relative. But I want it absolutely from below. It will look like this. We are increasing slowly the force, then we have reached 800 Newton, and then the motion is finished. Now you see condition is now changed to force. The next step is I want to stop the measurement, and then we are going back to home position. So we have the quite easy cycle like we saw in the presentation. We can increase this one a little bit. It's the maximum force and the minimum force. So we can go up to 1,500 Newton plus and 1,500 Newton minus. And now let's go through it again. So first of all, we start the measurement. We are going to the idle stroke. Home position is 0 millimeter. So we will go down to 75 millimeter with 200 millimeter per second. And we will have a look if the force exceeds 100 Newton. If that's the case, we will directly stop and we will receive an alarm from the system. So the next thing is joining stroke. If we have reached the 75 millimeter, the spindle will automatically slow to 5 millimeter per second, and it will go maximum to 83 millimeter. But the condition is force. So if the force occurs between 75 and 83 millimeter, the spindle will stop, in this case at 800 Newton. Then the measurement is stopped, and then we are going back to home position with 200 millimeter per second. And then the PLC programmer receives the information, okay, sequence is finished, do some handling in the machine, exchange the part, whatever. That's it. Not too hard. So now I just want to show you the automatic screen or the automatic mode. So if we are entering the automatic mode, all signals from the PLC side will be cut off. So now we have full control with the maXYmos NC. Like usual, always power on the system. Make sure that you're into home position, and then you can start the sequence. Now you see the force is increasing, displacement is increasing. Now maybe a bit delay on the WebEx. I don't know if you saw it just like me, but you can trust me, the spindle was driving. And now we can go back, and here we have our curve. So now we saw here we have 500 Newton, here we have 1000 Newton, so this could be somewhere at 800 Newton. If you want to make sure that it's 800 Newton, you can use this cursor function. Just type at this button, and you can switch. It's quite easy with the mouse instead of the display module, but both is possible. So here you see, oh, okay, we exceeded the force a little bit, but we will take care about this later. First of all, I want to arrange the zoom settings in a better way. So the easiest way is to arrange the zoom settings is, okay, press automatically, but then the device will have a look that the whole measurement is shown in the display. But here you see, during this 75 millimeter, nothing is happening. So it's not necessary to have a look at this one. So that's why you can choose the scaling manually. Just push that button, this one. And then you can choose the scaling manually. Let's just take our movement position. So it's from 75 up to 83 millimeter, from 0 Newton up to 1000, for example. If you press OK, you will see the curve like this, looking pretty good. You can save this one. So you save the screen settings or the zoom settings for the measuring program number 0. So that's how it looks like. So we have here our 75 millimeter, our idle stroke. Here in this area, already around with 5 millimeter per second. And here in this area, it's about 80 millimeter, 80.8 millimeter. We are going against the screw in the rubber. And here we have our typical view when we are going on a hard mechanical block. And we end up at 864 Newton. Okay, so now if you want to have an evaluation, the easiest way is if you press into setup, go to the measuring program setup, select your measuring program, and then choose the evaluation screen. So here you can choose up to 10 different evaluation objects. We are talking about this one and the details at the third part next week. But I just want to show you the basic things like Unibox or something like this. But here you see it's quite a lot of numbers. So for each application, there is a fitting evaluation objects from our side. So, but first of all, there's the capture curve screen. So now you have a few possibilities to get a reference curve. You can now start and process manually or automatically. You can grab an existing CSV file from a pen drive, for example. But what it's often used is history buffer. So we just pressed one cycle. So if you select a source history, you can go into automatically, it will guide you to the history buffer. Then you can choose some filter functions if you're already on a working machine. But now we have only one curve, so it's the decision is not too hard. So okay, you can apply this one, number of curves. You can also type in 1. And then the curve will be imported here. And here is the only possibility to see how much measuring points you have overall, the whole measurement. So we have 388 measuring points. But do not forget, we also measuring the position from, or the force and displacement values from 0 up to 75. So we are losing a lot of measuring points. So we will see this one if we zoom in the curve a little bit. So let's go back to the evaluation objects. That have to do the scaling again. It's the same like I already did in the current curve screen. So now we can go from 75 up to, what was it, 83, I guess. 0 Newton up to 1000 Newton. And then you see the curve like this. Please do not forget to save. And now we can work with the evaluation object. So let's start with the easy ones. As I already said, next week evaluation object is the topic. So here we have the Unibox. Like the name says, you can really decide what is the entry side, what is the exit side, should the curve be outside. So for example, let's use the first one like this here, for example. Okay, there's a no-go area. Curve is touching this area. It will be automatically marked as NOK. Could be an option. The second one, let's use a standard Unibox just to check the force before we are reaching block. Entry side is left and the exit side is right. And then not only Unibox, let's take a line X or something, just to check if we have reached the 800 Newton, what we want in between a specific area of the displacement here, for example. So, as I already said, next week we are talking about evaluation. This is just an easy example to show you how you can set up your process view. Okay, so that's it. We've done our evaluation, and now you can have a look at the process view. A really good thing is you can place up to 3 different values directly in the current curve screen. So if you enter this setup here, you see that's the current curve screen, and you can place up to 3 different values. There can be values from evaluation objects, for example, the maximum force. Yeah, that's the no-go box. Doesn't deliver any values, but this one does. So here you can, for example, can grab the maximum force of the evaluation object. But it's also possible that you grab some general curve values. These curve values are independent of your evaluation objects. These are always available. The other ones are only available if you set up the right evaluation object. So what's always a good thing is if you display the maximum position, in this case it's called block X, and in this case block Y is the maximum force at the end of the process. So if you set it up like this, that's the first step. And the second step could be, let's add some values to the value table. So if you press on configure, you can also set up the same values, but doesn't make sense at this time. Now I just want to focus on the Unibox values just for an example. So for example, you can have for this window, you can have the maximum force inside of this evaluation object, and you can have the according displacement value. So this max is the maximum force inside of the window, the force value, and the according position value. But it's also possible, for example, if you want to get displayed the lowest force inside of the window, it's also possible. So you can select Ymin Y, and of course, the according displacement value to it, it's Ymin X. And the last line, it's only a line, only delivers one value. So here you have the entry value. Okay, so now we have a few process values set up. So let's work with this one. Okay, and now let's drive another cycle. Let's go to service, automatic mode. Yes. Power on and start and cycle. Done quite fast. And now if we are re-entering the current curve screen, you see what's changed. Now you directly see what is the maximum displacement value. So this 81.03 should be the value here. Yep. With 2 decimal places. And you also see the 859 Newton. It's 860. Okay, maybe one Newton difference in this case. Okay, but here you directly see the maximum displacement value and the maximum force. But you can also display any important information from your side which you want displayed with one view. The other possibility is if you're using the process value table. Now you see the 203 Newton. It's the maximum force here in this area. We will see we become the according displacement value to it, and also the second values. The second values are the minimum force inside of this area, and of course, this 81.01 is the displacement value when we have crossed the threshold. So there are so many configurations possible. I told it a few times, but again, if you're interested in the evaluation objects, next week is the part where we are talking about it. Okay, so now I would like to show you some easy optimization of a process. So now we have a quite easy process, one idle stroke, one joining stroke. We would like to shut off at 800 Newton, and now you see, okay, we exceeded about 60 Newton. How we can fix that? There are more or less 2 possibilities. So the first easy one is you can have a look with the cursor function where are we going on block, on which position. So each part is different, maybe different tolerances, but it should be more or less in the same area. So here we have 80.6 millimeter, and at 80.9 or something, we are going on block. So let's choose 80.5 millimeter. So now, to reduce this exceeding of the target force, we can implement an additional motion. So let's keep this one as our block motion. So now we rename this one. It's block now. We can increase the speed down to 1 millimeter per second to avoid an exceeding. And now we can have another joining stroke motion. Let's go to 80.5, I guess. Yeah. Let's go with 5 millimeter per second. Position is okay. And this one, nothing changed, only the name. Now we will see what is the difference. So remember 859. Okay. Now we have 809. So we reduced it down to Newton with only one additional motion. And if you worry about the cycle time, it doesn't really change the cycle time, because if you have a look here, we are reducing the speed at 80.7 millimeter and we're stopping at 81. So we are only driving 0.3 millimeter with low speed. That's okay. That's not a big problem. But now it's also possible to go with that in this area. Instead of 5 millimeter per second, you can also go up to 30 millimeter per second. The only exception is, overall, our joining systems, if you have a process like this, if you go on a hard block, please do not exceed 10 millimeters per second. That's really important. But if you're just driving on a force where you can hear linear, with a linear increasement, it's not a problem. You can also drive with 20 or 30 millimeters per second. That's okay. The only limitation is really just to avoid any damages on the mechanical part of the joining module. Please do not drive more than 10 millimeters per second against a hard block. You will exceed the target value big time, and also it's not worth it, because the joining system can be damaged. And of course, you won't really decrease your cycle time. If you use a setup like this, it's much better, and it's also regarding the cycle time, it's quite faster. Okay, so now change this one. You will see it's also working with 20 millimeters per second. And now you will see a difference here, maybe, because if we are going fast on the rubber and break down immediately, you may see some spike. No, not really. Okay. Because here you see we are reducing the speed, and then we are going on to block. If you're working with some hard metal or something, you won't see any difference regarding the speed. But with some rubbers, there are sometimes a difference. And now you see we just exceeded 808 Newton, so only 8 Newton difference with only one additional motion, and even the cycle time now is even higher. So there are a lot of different possibilities how you can optimize this profile, the joining profile. Another thing is, what I often seen is, now if we have a look at the sequence, so now we are controlling, oh, I forgot to change this one. Now we are just controlling that nothing is going wrong during the idle stroke. So now we have a look that the force is not increasing 100 Newton. The exception is when we go and block with 800 Newton. But now here you see we are not checking if the force during the movement back on home position is lower than 100 Newton. So if you would do that in that way, I saw this a lot of times. So let's change this one. Remember, here we shut down at 800 Newton. We are stopping the measurement, and then we are going back to home position with a maximum limit of 100 Newton. So now I try, did you see what's happening? I try to run this one with my PLC. Just a moment. Oh, okay, it's working. Okay, so now I just started a cycle, and here you get an alarm. Maximum force out of range. Here we have 100 Newton. So we need to stop it. Just a moment. So, okay, now I can acknowledge it here. Now what is the problem? I've chosen this limit too low. Here we have only 100 Newton, so we need to increase this one. And we can, let's also go to 1500 Newton like this. Then let's do it again. Let's go in home position first. I need to do it from this side. Home position. Okay, and now another cycle, so we fixed that one. So and now you see we have also message, and it displays maximum force out of range. And now what is happening? Now we can use the sequence screen, and now you see we have exceeded this 100 Newton doing the home position, because it's clear we shut here down with 800 Newton and we stop the measurement and jumping back. So we need first of all a motion where we are able to cover more than 800 Newton and not directly go down to a limit of 100 Newton. This is not working. That's reading common used error on site. So now I first of all need to reset the error. Okay, then we can go back to home position. You see, now that's happening when now the operator of the machine is pressing go back to home position. We still have 180 Newton, and remember the limit is 100 Newton. So still, every time the error occurs. So we can easily fix that by resetting the piezo. Now we needed to do it a few times, and then we can go back to home position. But that's not way to cover your home position. So the easier way, and of course working way, is if you also do an additional motion during the home position. So for example, remember I told you reference can also be relative, and now we can first of all, before we are going back to home position, we can go 10 millimeters back with, let's say, 20 millimeters with a high force limit, and then we can go with this low force limit of 100 Newton. That should work without any problem. So let's try it again. So now it's working without a problem, and you see we are back in home position without any alarm message. So that's a really good thing, just to read the part before you're going to back to home position, when you want to just have a look at the force at the movement back to home position. So now let's give this one a release. And what I'm often doing is I'm just switching off the home position of the sequence. This is also possible. So you can set up the big limits that you always be able to go back in home position and just add another motion with 0 millimeter and call this one also home position. Let's say it is 200 millimeter per second, and again the low force limit of, I think, 100. So now we first of all releasing the part of 10 millimeters. With a real part shouldn't be 10 millimeters, but in this case with the rubber it's okay. And then we can go back all the way back with with maximum force of 100 Newton. If something happens, then the spindle will directly stop. Otherwise, we will have a problem. And this home position is now only used if the operator of the machine is pressing go back to home position in manual mode. So normally it won't be used. That's also a possibility how you can fix things like that. So now the same function, but we are not using the automatically home position sequence element. And the PLC programmer receives the same information. He receives also I'm in home position, even if he's not using the home position element. But if you're using a normal motion and displacement value is equal, so both is 0 millimeter, it doesn't matter if you're using the home position element or not, or a single motion element. Yeah, okay. So I would say that was basic stuff for the first part. Now I would ask you for some questions. If you have any questions regarding the percentage, just let me know, or let me and my colleagues know.
Okay, let's check the Q&A box and see if there are any more questions. Okay, we are receiving some appreciation regarding our product. Thank you very much.
And Peter,
Yes.
would you be so kind to spend some words also regarding how to manage ID generation and the measuring programs in the measuring program manager, like copy, restore, and things like this?
Yeah, of course. Sorry, I forgot this one. Yeah. Okay, so of course, if you go back to the measure.
I'm sorry. If in the meantime our listeners have questions of what you have already seen, please submit your questions and we will take care of it. Okay?
Okay.
Thank you.
Okay, so now a few things about the measuring program manager. So now we just set up a complete measuring program. So it doesn't make sense, for example, if you're working with a machine, 2, 3, or 4 different parts or whatever, and you always need to do the same stuff like we did it 4 or 5 times. So the easiest way is to simply copy and just copy the program. So for example, copy the program, set it to, for example, measuring program number 2. Give it another name. Okay. Then it's also activated. And then in the most cases, you just need to change some details. For example, some target positions, some forces, and so on. So that's the easiest way. And the good thing is also all the process view and so on, like current curve, or for example, the process value table is also copied. And if you are changing the position of the evaluation object, you don't have to do it again. And of course, later on, and also in the webinar, we are talking about some data export, for example, QDAS and something. And QDAS, here you can set up also all different values for program, for example. And if you need to do that 4 or 5 times because you have different parts, different programs, it's always a good idea to first start to make a template. Let's name it a template program, for example, and then simply copy all that stuff and simply changing the details, because all the process view information, all the parameters for data export and so on are already implemented then, and that's quite easy. And also, it's not only for that single device, it's also, if you imagine you have an assembly line, for example, 4 or 5 systems in a row, and you are setting the, one device up, you can also I can try it. I can implement in pen drive now. I just plug in pen drive now in my maXYmos NC, and then it's quite easy. So if you plug in a pen drive, this will not be grayed out anymore. And now you can, for example, select a measuring program and save it to the pen drive. And then in another machine, you can restore this measuring program from the pen drive, and you have exactly the same settings for each measuring program. All calibration settings, like for example, in the beginning, sensitivity values from measuring range 1, measuring range 2, and so on, will be not touched, only the measuring program set up. Of course, export functions and so on, you can do it like that. Okay.
Peter, I have a question from one listener saying, what is the bit, the signal to be used to launch the break test if you want to make it by a PLC?
Okay, I can show it. So if you have a look at the field bus information, there are a few bits regarding the break test. So here on the left side, we have the input bits, C to the maXYmos. On the right side, we have the output bits, maXYmos to the PLC. So now let's have a look. So here we have the first one. It's bit 9.7. It's the manual break test. So you can set this one. And there's also an output for it, which is called break test done. It's also 9.7. So first of all, you need to set the input bit or input byte 9.7 and wait till 9.7 is also acknowledged. That's the way how you can do annual break test. But one thing is necessary. Please do not forget to activate the break test function, because if you do not activate the break test function, this timer is not running inside of the drive. So you need to enable this one first. Otherwise, it will not work. But that's the two bits. There's another one. I can show it. Let me search for it. It's something like break test. Here break test required. Yeah. If the timer is off, so it's normally 8 hours. If the timer is off, this bit will be sent. It will be automatically performed anyway with the next start, but here is the information for you that the break test now is required. And if the speed in the next 15 minutes, that's the timer also in the drive, is not moving, you will get an alarm message from the drive that you exceeded the maximum tolerance time for the break test. Then you need to acknowledge this one, and then you can do it manually or automatically with the next start.
Okay. Any question about sequencer and the motions and how to increase the resolution of the system? We are available to answer you.
Yeah, otherwise, on Thursday, we are talking about in the details of if there are any questions left, just let us know.
In the meantime, I would like to recall, to make a reminder for you for the next session in the next days. The second session, there will be, it will be in 2 days. And we will talk a little bit deeper about the sequence editor. In the third section, we will have contents regarding the evaluation object. In particular, we will go through all the Windows evaluation object available, and some advanced configurations regarding the hysteresis in the catch zone, for instance.
Yep.
In the fourth session, we will talk about how to implement either an external sensor for the channel X or Y, it means in displacement or force. And then we will have a look regarding the export of files in the formats and how to perform the actual and traceability of the cycles. as well as the usage of the offline tool. And in a section, we will have the possibility to explain you basic concept regarding the safety technology of our joining systems, and give you an overview of our joining competence center. So please, if you didn't apply yet, we would appreciate to have you as to attend these more sessions.
Okay, thank you for participating to this webinar. In case of any questions, please contact my colleague giuseppe.lamacchia@kistler.com or me, valentina.zucchelli@kistler.com, and we will answer you privately. We will send you a webinar recording in a following email. Thank you for participating, and we were looking forward to present you the next sessions of this webinar during the month of July. Thank you for your support, and have a nice day.
Bye. Thank you for attending.